Hello, and welcome to How to Engineer a Sustainable World for This is Engineering Day. Thank you for joining us. I'm Poppy Morgan, Campaign Officer for This is Engineering, and I'll be leading the talk with our engineers today. As part of This is Engineering Day, we want to celebrate how engineers make a difference in our lives, from helping the planet to helping develop the latest medical marvels. This session is part of a series we've been hosting today. We've had 4 other fascinating topics, and all of these Q&As will be available to watch online afterwards, so you'll be able to watch later. We're also excited to say we're releasing a preview of a new virtual museum, the Museum of Engineering Innovation. Visit the This is Engineering website to find out more about the engineering in theatre, medicine, and sport. Engineers are behind many surprising things in our lives, and the future of the environment is no different. From clean water to clean energy, engineers are working towards the solutions to a cleaner future. I'm joined by 2 wonderful engineers today from This is Engineering and the University of Warwick, who are going to share their insights into how to engineer a sustainable world. Would recommend setting your Zoom to gallery view in the top right corner so that you can see all the speakers on your screen. You can submit your questions via the Q&A button at the bottom of your screen. You can do this at any time, and you also have the ability to vote on other people's questions so we can see what you're interested in. Feel free to put your first name down or your school or class name if you want to shout out when we ask the question. I'm really looking forward to today's talk as our engineers come with experience in clean energy and preventing flooding. Thank you both for joining us. Millie currently works for Arup. And Millie, would you like to tell us a little about yourself and your engineering journey?
Hi, my name's Millie Hinaika, and I'm a civil engineer at Arup. So I work mainly on sustainable drainage system design to manage rainfall and on flood defences to protect towns and cities from river flooding. I got interested in engineering through the Engineering Development Trust and my school teachers, and I ended up studying general engineering at the University of Cambridge. My work is really varied, so I've done some work on site supervising construction, but also lots of design work in the office. And in terms of my passions and what I'm interested in, these have definitely developed over the years. So I got involved with Engineers Without Borders UK when I was at university and saw the importance of engineering and improving people's lives. And got interested in international development. I've also done some volunteering with them abroad. And the charities I worked with have shown me the importance of how we engage with communities and give them ownership of the projects.
That's fascinating. I'm really looking forward to hearing about your sustainable drainage and the infrastructure involved there. And our second engineer is Richard. You're at the University of Warwick. Please tell us a little bit more about yourself.
Yes, indeed, Poppy. I'm at the University of Warwick in WMG. WMG was founded as the Warwick Manufacturing Group by its founder, Lord Bhattacharya, as a department with a particular focus on supporting industry, which I'm very happy to do. At WMG, my original role was to support the electrification of transport, mostly automotive, but increasingly we're thinking about marine and aerospace. And of course, that immediately spilled into whole issues about how we generate the electricity and then how we use electricity in general, energy issues, clean energy, and so on. Going back a bit, like Millie, I studied general engineering at Cambridge, but specialized in electrical papers in my final year. I was then persuaded by my project supervisor to stay on and do a PhD. And you won't believe this, but at the end of my PhD, I turned down a job in California, yes, California, to stay on and do research. And later on, I got a job on the faculty at Cambridge. And then later on, Warwick approached me and said, look, we really need somebody who knows about electrical things to come and help us with electrification of transport. And that's where I am now.
Perfect. And electrical vehicles, we're always talking about those. You can't move for adverts for them now. So really interested to dive into that as well. So to get started, I'd really like to know about a sustainability project that you've been really excited to be involved with. So Millie, let's start with you. Tell us more.
I guess one of my favourite projects that I've been involved in was the Leeds Flood Alleviation Scheme. So it's a project which protects the city centre of Leeds from flooding, and any project where looking at flood alleviation, you have to account for climate change in your design. So how is the design accounting for how the climate's going to change and how that's going to impact people's lives, especially in terms of river levels and river flows and rainfall and things. So the project is in the city centre, and the innovative aspect of the project means that we've done lots of works in the river channel, and the walls in the city are much lower than they would have needed to be otherwise. So people are still connected to the river, which I think is a really cool part of the project.
That's fascinating. And yes, because you live in Leeds at the moment, so you get to see the world around you that you've helped been involved in.
Yeah, it's very exciting.
That's fantastic. And Richard, what sustainability project has really captured your heart?
Well, I'm going to cheat slightly, Poppy, and mention two runners up first. One is a combined solar battery system which powers the air conditioning in the Rosie Maternity Hospital in Cambridge, which is using much less mains electricity. The other one is helping a nearby company to move from being an automotive supplier to an electric vehicle automotive supplier. But my own personal project came from an interest in how we're going to deal with the problem of heating our houses. At the moment we use gas that emits quite a lot of CO2. Heat pumps are talked about as a solution. I thought, well, come on, Richard, put your own heat pump in, see what it's like, so you can actually talk from experience rather than just the literature. So I put one in with the help of retired army colonel who'd started a business. We went through the calculations. I was assisted by a brilliant modeler from Portugal. We installed it, and this is always good. It all worked, and I'm going to boast, Poppy allowed me to have this boast, in 4 years of operation, I have saved 10 tons of carbon dioxide by moving from the previous oil heating system. And obviously this is informing, I mean, I'm working with a property developer to how we can start rolling this out based on real experience.
Perfect. So again, you are surrounded by your own engineering where you live.
Right, so.
No, that's wonderful. It's great because engineering can sometimes not seem very tangible because so many people don't realise exactly what can be done behind our homes and cities there. So we actually had a pre-submitted question which I'm going to direct towards Millie. So how do we make water clean?
So this is not my area of expertise, just to put it out there. But a lot of my colleagues in the office, especially the process engineers, are very involved with clean water treatment systems and treatment works. So normally, if you started with young kids, you'd say, look at filtration. So any water you have, you'd want to get rid of any large matter in the water. But then you'd also need to treat it with chemicals to make sure that you kill off any E. coli and other biological matter in there as well. So I used to run some outreach workshops when we were at university with younger students, and you could get them to just put things like sand and gravels in a bottle and some activated charcoal at the bottom. It's really impressive how muddy water can turn really clean. But obviously that is not suitable for drinking unless it's been tested.
Absolutely. And Richard, you were talking about the electrification of transport and how much that has shifted in recent years. You started with, you said automobiles, cars, but now you're looking to the skies and the seas as well. So tell us more about the future of transport and if the future is electric.
Well, predicting the future is always dangerous, Poppy.
I'm still going to make you do it.
But from what it looks like now, the future will be more electric, and particularly with land transport, I think more autonomous. Depending on if you're in Milton Keynes, you might have seen the odd pod trundling around. Driverless trains have been with us. I'm sure there'll be more autonomy. So I think that will be interesting. But I always remember that if we go back 120 years ago, we had a previous electric revolution with many electric cars, electrics on the railway, electric trams. And then, of course, this internal combustion thing came along and knocked everything off the track. So maybe there'll be things like hydrogen or ammonia as fuels, which will disrupt the progress. turning to marine, I mean, already we're dealing with things like when cruise ships come into port, we don't really want the diesel engines producing a black cloud over Venice, and we can connect up to shore power. So we are making real progress with that. A lot of ships have electric drives now, which leads to a lot of energy saving. But unfortunately, we don't have a big enough battery that'll take you around the world on a big ship yet.
Oh, okay. Well, that leads nicely onto one of our other questions we received, which perhaps I'll start with Richard, and Millie, you can say if you want to add anything. How can we make battery-powered electronics last longer then?
Well, you can attack it from both ends. You can make your thing consume less power, and there've been some fantastic advantages in silicon chips to reduce the amount of power. And one example that's often talked about is so-called wearable healthcare. If my heart's a bit troublesome, I could wear something, and that chip must use an absolutely minimal amount of power. So you can attack it from that end. But then software writers write code that consumes more power because every computation uses a little bit of power. So that's another thing. Can we go back to writing efficient code? And then the third thing is, can we make batteries better? And I think the answer is yes. But it takes time to develop batteries. I mean, people say, oh, we've got this wonderful battery in the lab. That's fantastic. Material scientists, brilliant people, a lot of friends. But to make that an engineering reality is quite a journey.
And a journey I'm sure many engineers are currently pursuing.
You can say that, yes.
And Millie, you talk about working with river flows. So in a previous talk, we were talking about symbiotic engineering and nature. So are you often inspired by nature or working with nature to create these sustainable drainage systems that are helping whole cities?
Yes, definitely. So I've been working with a colleague recently on large master plan scheme trying to design urban drainage. And instead of just doing normally traditional drainage at the moment, it's all about putting big pipes under roads, and then you get all the rainfall into a pipe and then discharge it into a sewer or a river further downstream. But actually we want to mimic what the natural systems are doing. So can we capture the water where it falls and then slow it down, maybe let it infiltrate into the ground instead of just putting a whole load of water further downstream. So when we're doing that, we look at we try to create systems that do mimic what happens in a natural setting, and it actually then results in a design that's much more pleasant for users. So you probably have more trees, maybe rain gardens. You could even use things like swales, which are like mini rivers or small ponds to attenuate and slow down the flow. So yes, definitely get a lot of inspiration from nature.
That's fabulous. So we can see our infrastructure becoming more cohesive, and we're talking about the future of cities quite often. A question that often pops up though, because you're both in quite different fields, how do you get better at knowing the technical terminology? For someone looking at entering engineering, sometimes that can phase us when we don't know precisely what a word means. So Richard, I'll start with you. How do you just get better at knowing all of that vocabulary that's so specialist?
You make a very good point. A long time ago when I studied engineering, it was probably possible for one person to know most of engineering. That's long since passed now. I don't think there's a simple solution. A glib answer is there's some remarkable resources on the internet now to help you discover the 3-letter acronym, which now probably means 5 different things. And the other thing is simply to study, try and keep up to date, read the literature.
Perfect. And Millie, what about you? How have you found your journey wading through the terminology that pops up?
Yeah, I think Richard's got to hit the nail on the head there. The internet is your friend when it comes to finding out what things mean. But I think also just, like you said, reading around, and I find the people around me are great resources for, if you've got a question and you don't know what it means, whether it's kind of your fellow students, people you're studying with, or people you might have come across in the workplace. So even if you don't know it, someone else might.
Perfect. So collaboration and curiosity all round.
Yeah.
That's wonderful. And we've had a question through. Obviously, feel free to answer personally or from the perspective of a project you've worked on. Richard, what would you like to see in a smart city?
a great place to live. And now what does that mean? I mean, I'd like to feel that the buildings were comfortable, enjoyable to live in, that we had good communications with other people. What is the technology underlying that, which maybe is a bit behind the question? We can use, glibly called the Internet of Things, building energy management, so it's more comfortable, uses less energy, maybe uses a bit less water, but Millie might come in on that one. And then there's the whole idea of transport as a service. You know, many of us own cars and they just sort of sit there. Maybe if we had one of these clever apps, you know, we dialed up something that rolled up in front of the house and took us to where we want to, would we prefer that? So those are some of the things, and a nice environment.
Absolutely, the number one priority. And Millie, do you have any dreams about what the future cities might look like and how they can be sustainable?
I think I'd echo a lot of what Richard said earlier as well. I think a city that is just really pleasant to live in and needs to move around in. So, you know, at the moment, if you go to a city centre that's full of cars and buses and things, it's not so pleasant. So if we can get rid of individual cars in the city centre and just have more public transport and cleaner public transport, and you know what he said about using less water for buildings and for just for what services are provided, but actually if you've got better drainage, for example, you could create more pocket parks in city centres and create spaces for you know, create more biodiverse environments. So you're creating space for the environment as well as for people. I think it would just mean it's much more of a pleasant experience for everyone involved.
That's perfect. And to talk more about your engineering journeys, what were your favourite subjects at school? I'll start with you, Millie. Or what was your most useful or valuable subject at school? That they don't have to be the same subject.
I really enjoyed maths when I was growing up, but I think that's partly because I moved between countries when I was younger, so it was definitely the subject that was the most consistent across countries. And I did also enjoy learning languages, which I did to A-level as well, because I think it's really important to keep on studying things that really interest you, because you don't know where that might lead further down.
Perfect. And Richard, back at school for you, what was always a favourite subject and what has been really valuable for you in your career?
Trouble is, I didn't have a favourite subject. And like Millie, I was across the board. I really liked languages, although I think probably in retrospect, I was more interested in the structure and the grammar rather than the literature side. And I was not too bad at sciences too, and even occasionally competent at maths. So in the end, I took maths, physics and chemistry. It was a normal thing in my day. And actually chemistry in a way was my favorite subject, and I was probably best at chemistry. But I felt, and I should say I grew, at secondary school, I was in Rugby, which at that time was a great electrical engineering town, and there was a lot of influence there. And I think that probably encouraged me to follow the electrical engineering route.
Perfect. And almost then on that level, it sounds like it's a love of learning and curiosity that no matter what the subject is, that's kind of the core little nugget perhaps of being led into engineering, is just always asking questions and knowing a bit more. So Millie, if you weren't an engineer, what do you think you'd be?
That's a really hard one.
Yeah. I didn't say I'm going to be easy questions.
I'm not sure. I think if I hadn't studied engineering, I probably would have studied something like geography or languages in hindsight, because I think I see a lot of, I mean, I have a lot of colleagues in our firm who are geographers by background, but then, you know, we work very closely on the built environment aspects together, because, you know, it's not just engineering, there's a lot of different people involved to make things happen. Perfect. But it's a very hard question. I'm still trying to figure out what I want to be as an engineer.
A perfect answer. You don't have to be put in a box. Richard, do you have an equally turbulent answer, or do you know what you would be if you weren't an engineer?
I do like geography, but I think I would do history, particularly technical history. And just to give a brief example of that, I'm currently talking to some people at the Ironbridge Gorge Trust, where there was one forgotten engineer called Thomas Parker, who started out as an iron founder and then started many companies, some of which still exist today. And I would love to have the time to do the research and write a biography. Maybe I'll have to get somebody to help me. But yes, I would have loved to be a historian, because I agree with my historian colleagues. I think we should pay more attention to history and learn from it.
Perfect. And we've had a question come through about maritime transport and the need to re-engineer. So I'm going to direct this towards Richard and saying we see many ports around the world with ships queuing to enter for days. E-navigation may be the key to tackling that and how that's engineering. Is that something that you view a sustainable way in improving the maritime industry as well, especially with transport?
I'm not sure I know much about navigation per se, although I've managed to cross the Solent without crashing into anything. But I'd approach it from a slightly different direction, that planning the movements of ships is really important in terms of energy efficiency and also business efficiency. And the more we can do there, the better. In that if you go another knot faster, you use a lot more energy, but you don't want to be late for your slot into port. So I think your questioner really has a finger on the button there about how you can avoid, how you can be more efficient in that. And I think quite a few things will contribute to that.
And that sounds quite similar to what Millie was talking about earlier. It's whole systems that become more efficient, and yourself talking about batteries. By making those small changes at the fringes of things is how we make entire systems more sustainable. We've got a question about solar energy, so I'll pop back to you, Richard. Do you see solar energy as being very important in cities in the future? A simple question for you. How important do you think solar energy will be for cities?
Considerably important. I mean, I go back to I mentioned the maternity hospital in Cambridge, where our industrial partners put a solar panel on the roof, a mini solar farm, and that's providing a substantial amount of energy for the air conditioning system. So we've got all those we've got those roofs. Millie and her colleagues will make sure they're capable of carrying solar panels, put them up. I mean, we've talked to distribution center owners, get solar panels on your roofs, because you can generate a lot of power. Now, the only problem is that the sun goes to bed every day. And so we've got to think of ways of either storing energy or being able to use the energy when it's available. But I see a great future for solar. I mean, you only have to look at the huge amount of investment going into solar farms around the world to know that.
Thank you very much for that. Millie, if we go back to you, what's one piece of advice you would go back and tell yourself or tell a budding engineer when starting out in engineering? What's one piece of advice you'd like to share?
Oh, I'd say, I think what we talked about earlier, really about being curious, because when I started out, I didn't really know the different opportunities you could have as an engineer and the different career paths you could have, because I think it's really hard to know when you're not in that field. And throughout my time at university and since I started working, just meeting lots of different people and finding out about the really inspiring things that lots of engineers are doing around the world. And I think just because you might not see someone at the moment who you think you could be or who you think is doing something you're interested in doesn't mean that engineering isn't a career for you. You might not have met that person yet. So definitely follow what you're interested in. And ask lots of questions, and if you're interested in solving big problems, I think it's a great career.
Perfect. And the same to you, Richard. What piece of advice would you give to yourself or to a budding engineer?
Well, I think the first thing is to underline something Millie said, just ask lots of questions. I like to get to the bottom of things. I mean, just to give a trivial example, I'm working with somebody who's running a solar farm at the moment, a lot of problems. What's going on? The contractors throw out all sorts of explanations. Well, maybe true, but let's get to the bottom of it. We must understand it. And the other thing, going back to the question about learning about things, is don't be embarrassed to admit you don't know or to ask questions. It's much better to do that than to blunder on, because you're actually engineering things have a real impact on people's lives, and you're under an obligation to get things right.
And on that note about blundering then and learning, have you, and we'll start with you, Richard, have you had any projects that have failed and that you've had to learn and overcome?
Well, I will get my get out of jail free in first, that I'm on the research side. So I'm allowed to try lots of things in a way I don't think Millie is, to see what works and doesn't. And yes, we've had some projects that either have stopped because we realized that it wasn't technically possible at this time, or just have gone wrong. And one of mine, I was part of it, even got on the television as a wreck visible off the coast of Lowestoft. That wasn't a good day.
It wasn't a good day, but hopefully lots of learnings and collaboration.
Well, we're not the only one. One of my good friends at Edinburgh mailed me and said, well, Richard, join the elite club of those who are working in wave power who've had a disaster.
There we go. Well, there's some elite club badge of honour there then. And Millie, have you had any projects that have failed but have given you some interesting learnings?
Yeah, I think maybe not massive failures, but I think every day you're learning different things. And I think what Richard said earlier about being prepared to say, I don't know, or saying this isn't working, how can we approach this problem in a different way? And that's why, it's really great to be working in a big firm where I can say, oh, this isn't working the way I'm trying to approach this problem. Go and ask a colleague maybe who's got more experience and say, have you ever experienced something like this before? What have you done? And I think there's a lot of collaboration in all the work I've done at Arup, and it's been, I think that's something I really enjoy as well, being able to work with people who have very different specialities to you, and you're all working together to solve a problem.
Perfect. And just as we're coming to time, a 60-second answer from you. Richard, what's the best thing about your field of engineering? A nice, easy one.
No, it's not easy. I was going to go a little bit along Millie's line. I mean, just the opportunity to work with a wide range of really interesting people with a lot of skills, and I've learned so much. So that's part of it. And the other part is every project is interesting. I think of some of my colleagues saying law or accountancy. We have such a rich variety of projects in engineering, and the possibility of making a real impact either to people's lives or to companies or just human knowledge.
That's fantastic. And Millie, what's the best thing about your field of engineering? What do you love about being an engineer?
I think firstly, yes, it's all the kind of people I've come across and can work with, but so I think the main thing for me is finding something that you can see the social impact of the projects, and I think that's one of the main reasons I was attracted to water as a business. As civil engineer working in water, you get to really have a positive impact on people's lives, and I think for me that's really rewarding, and it's kind of what keeps me wanting to come back into work every day.
Perfect. Thank you so much for all of this discussion. It's been so insightful. We have reached our time for this session, but don't worry, as part of This is Engineering Day and tomorrow's Engineers Week, we have had 4 other fascinating topics, and all of them are going to be available to watch online. So don't worry if you've missed anything. If you have enjoyed today and you'd like to learn more, we have lots of case studies on our website, as well as a preview of our new Museum of Engineering Innovation. Visit thisisengineering.org.uk to find out more. For schools, Tomorrow's Engineers have launched the Big Quiz with 2 chances to win £1,000 prizes of STEM vouchers. Search Tomorrow's Engineers Big Quiz for more information. And for budding designers, the Queen Elizabeth Prize for Engineering has a Create the Trophy competition. Download that app to design in 3D and create an iconic trophy that captures the creativity and wonder of engineering. The winner will receive a state-of-the-art laptop, so search Queen Elizabeth Prize for Engineering or visit our website where you can find all of these details. An extra thank you to our wonderful engineers, Millie and Richard. It's been fascinating to hear their journeys and to hear about sustainable engineering. Thank you for celebrating This is Engineering Day with us, seeing how engineers can be the difference.